we figured since we have a session on FAIR, we might as well review what FAIR is and then talk about how it fits into just generally into the life cycle. And then we can talk about specifics and where we want to go from there. So FAIR is an acronym for a set of domain-independent high-level principles for data management. The acronym stands for findable, accessible, interoperable, and reusable. And these are the 4 terms that kind of serve as a way to group the principles. They were formally presented by Wilkinson and others in 2016, but this is after being developed through a few years of community discussion in the life sciences, which is where they arose. However, they are general, and they can apply to many different situations, and so they make sense just in general. The FAIR addresses the points that our data is spread over many different systems, and every system has idiosyncrasies, and that more data is always being collected, and that it is laborious and difficult for humans to find data. It is also difficult for computational agents to find data because of the lack of standardization between these systems. So, and then it's also hard to understand whether a given data set would be useful in a given context and can be reused, which is kind of what we all want. As we've collected the data, why not use it as much as we can? So another thing that the principles include is that algorithms, workflows, and other processing steps are important and should also be included when we speak of data. So in some sense, this is actually especially for 2016, this is sets a very broad stage. Like we want to be able to have computational agents access data, and we want to also, we also want to include more than just data. The algorithms and workflows are also important. So it is important to keep in mind as we list these that these are just principles, and that it's not really a standard. It's more of a direction and not a destination. So in that sense, like it doesn't. We can talk about things being fair, but really we should think about it as an incremental, always an incremental improvement over what we currently have, and that even just doing a little thing can help us a lot. So, okay. So just go over the principles. See, how many are there? I think there's like about 11. So let's go through them. So the first letter F, findable. There are 4 principles under this. So the first one is that metadata are assigned a globally unique and persistent identifier. This is perhaps the most important principle since identifiers are important and we need a way to name things that we can refer to at the other steps. The others are a little more straightforward. So second one, data are described with rich metadata, which is defined by another later principle. F3, metadata clearly and explicitly include the identifier of the data it describes. So this does recognize that maybe data and metadata don't necessarily live together, that they could be in different systems. F4, metadata are registered or indexed in a searchable source. Okay. The next principle is A for accessible. We got 2 principles. Oops. First one, A1, metadata are retrievable by their identifier using a standardized communications protocol. The protocol is open, free, and universally implementable, and the protocol allows for the authentication authorization procedure where necessary. These days, we probably just use HTTP, and then that's good. But since these principles are technology agnostic, it's good to at least state what our intentions are for this. And then the other one is that in this other, allowing for authentication authorization is okay. Data does not necessarily need to be publicly available to be fair. The important thing is just that it has a name and that people know where to ask to get it. A2 is metadata are accessible even when the data is no longer available. So this is also important because we want, if someone comes up later and they're looking for something, they at least need to know that there was something there to begin with, and that things just don't disappear. The next letter I is for interoperable. I1, metadata use a formal, accessible, shared, and broadly applicable language for knowledge representation. I2 is metadata use vocabularies that follow FAIR principles, and I3 is metadata include qualified references to other metadata. These ensure that we can understand other people, like metadata from different records or different systems in a standard way. And then the last one is R, which is reusable. And this is metadata are richly described with a plur. This is actually the principle that what does it mean to be richly described? Metadata are richly described with a plurality of accurate and relevant attributes. So there's 3 sub-principles. Metadata are released with a clear and accessible data usage license. Metadata are associated with detailed provenance, and metadata meet domain relevant community standards. So this is by the plurality of accurate and relevant attributes. This means that we have that well, we have a lot of information. When the data usage license is always important, right? Since we do want to be able to know when we can reuse stuff and when something is maybe more restricted. Provenance, this is simply keeping track of where things come from. And then, of course, community standards. This will vary depending on what exactly we are describing, but it should have enough metadata that the community in question, at least a domain that is relevant to, can easily find it and can at least make sense of it. So the exact attributes will, of course, vary from one domain to another, but the fact that we can at least have it on the data. So, okay, so now let's move on to how FAIR fits into the data lifecycle. So this is a diagram we actually saw earlier too of a generalized data lifecycle, and this captures data from the beginning, data capture through processing steps, through a storage and archiving step, through finally a dissemination step, and then that's kind of where we think of people like actually accessing the data. So the most FAIR principles seem like they only relate to the later stages, such as helping people define and access data that's already been produced. And then also a FAIR, of course, applies to archiving, since there's no point in saving data that we cannot find again. And these are important steps because there are many, especially FAIR definitely addresses this, because there are many places for storing data and portals for accessing data, and we want to at least allow even just meta indexes to be produced, so it makes it easier for people to find things. But counterintuitively, FAIR is also actually has a place at every other step in this process. So we know that data collection and analysis can be messy processes, and FAIR talks about the importance of identity. We need to remember which data was collected and with which methods. We need to remember which analysis used which data, and we also, and this points to the need for us to collect metadata from the very beginning, such as which model of sensors were used, which configurations were used. And the easiest way to do this is just to collect it from the very beginning. So rather than trying to retroactively figure it out. So, and it also shows how identifiers are important, since as we collect this metadata, we need an identifier to hang the metadata on so that we know what we're actually describing. And then FAIR also applies to scientific workflows, such as which versions of software were used and what were the steps used. And so these are all aspects of the initial processing pieces. So, okay. So this metadata is important not only just for like reproducibility, which is a can of worms, but it's also just a minimum to support reuse, since we have to be able to understand how things were collected in order to understand what reuse contexts make sense and are applicable and are scientifically valid. So this is just a summary of what I said. So this metadata and provenance, in particular, I'm gonna say this for Chuck, this is the AI ready aspect is especially important here, since AI can often find things in our data that were just noise from the collection methods. So it's important, and also, as we know with AI, it's only as good as the data it collects. If we know there's a systematic bias in the data, then the AI will inherit that bias. So it's good to know this. There are domain-specific efforts to, as they say, verify data. The GoFair website is one organization, and they have several community implementation groups that are trying to figure out how to apply data in a way that makes sense to different disciplines. So, and then I'm going to end quickly with saying that, as this is from a quote from the FAIR paper, good data management and stewardship is not a goal in itself, but rather a precondition for supporting knowledge, discovery, and innovation. And that we should keep it, and that this data management is a cross-cutting concern, not limited to simply to the archiving and dissemination phases of the data lifecycle. So, okay. Thank you very much.